This conference will now be recorded.
Okay. So Sumit has joined. I made him a join. Uh, who is this Isha? Okay. People are still joining. Okay. So hi all. Welcome to another day on this performance testing with JMeter Course to advanced level code. So today will be last day, I think, discussing the core concepts. So it will be day 6. What we are going to discuss is first client side and server side. Okay. So on any application, okay, uh, I have explained yesterday that we have a request and we have embedded resources. Correct. So any application you will open, a Flipkart or anything. So you see Flipkart has opened up. Now there are three things to understand. Okay. First thing is this is the main request which went to the server and we received the response, which will be in code form. This is the code form. Now, yeah. Now, so there is a time for that. Okay. So if you see, the request went, right? The request went and the response, and then there is a time for that. You can see that time over here. So that response which came in code format, okay, code or text format. So that is purely called server side response. Server side response. Okay. And generally, in most of the performance testing, people focus on this time only. Even in API testing or whatever, microservices testing, DB testing, this is all. This is the main thing we focus on, right? So, but so this time, you can say, let us say, let us take it as a T1, okay, T1, T1. Okay. Got it right? No confusion. Now, once this code comes to the browser, after that it is rendered, right? This whole thing is downloaded, embedded resources, and all the things, and then that is processed also, and then we see this beautiful image. Right? So this is the downloading and processing. Correct. So there is a another time for that. So in that there is a time for downloading of all the embedded resources. So that can say T2. Sometime you can take, like, let us say 2 seconds, and then processing and making it available, the page which look like this. So that time also, which is T3, time 3. Okay, T3 means this is a time one. Here I am saying T means do not understand it as a transit. It's time one. Okay, time one, time two, and time three. So time three, let us say it's 1. Now, this is the main response time, right? And most of the performance testing focus on this time only. That you are sending the request, right? Sending the request, you are receiving the response. That response comes in code format, and we just measure that for multiple users, right? So we measure the T1, and that is pure server side. Whether it is normal web application or web services or microservices, DB queries, everything. It's like that. But when it comes to after that, right? So these two activity, the T2 activity and T3 activity, downloading and processing. This happens on browser end, right? Browser is doing that, and plus browser does that, right? After it receives the response. So this is called client side. What it will be called, client side or client side activity, right? Client side activity. Client side. Client means user, a user end, user side. So in that T2 and T3 are there. Now if you add this whole T1 plus T2 plus T3, right? This that is called total response time, which is called end-to-end response. End-to-end response time. Okay, response time. Got the idea? Now, if you see here, the blue one, DOM content load, you will always see this time of that particular request, which is server side response time, will be always less than this time. Okay, always less, because that is pure code, right? Pure code is thing. And after that, take some processing, correct? Processing. So that time has increased, which is T3, T3, and we see that, right? And then embedded resources also got 51. This is little time it got increased, and total time for this page load is this. Okay, 5.76 seconds. So which is a sum of T1, T2, and T3. T2 and T3 you cannot see directly, okay, because many things happen. And but this is the thing. You see the right. So the rate, the thing that is there in red color, that is load time, which is complete end-to-end T1 plus T2 plus T3. The time that you see here, that is T1, pure response time, and this is the time which is in middle before full processing, and then something is load. And that is how you see this three times. Do not see on this. This is nothing to do with finish. This is no need to go. So you can see this for any page, not only for this page. You can open any page and you can see. Okay. Now these two things, T2 and T3, since it happens on user side, right, and many dependencies there. Like suppose your laptop is slow, your browser is slow, you have less RAM, or your processor is slow, old processor, internet is slow. So obviously this rendering processing can take time, right? And if you have a very fast processor, high RAM, good laptop, right? So you will see it will be rendered more fast. So a little dependency is there, and that's why this thing is called user side or client side, right? And so that is the exact difference. Got the idea? And this is what three types of response time, and when we add them, it's called end to end. Otherwise, if we segregate them or separate them, so it's T1, T2, T3. T1 is the main one, right? Which we focus more. T2, T3 happens on user end. That's why it's not focused much. Okay, calculating the T2 or T3. Only when if required, people go means in the project if it is required, you can go and check for the this also T2 and T3. Now, while processing, what happens? Embedded resources is there, right? And in that, especially the JavaScript file and the CSS file, they gets loaded because that contains the structure, right? And that is what is called DOM, DOM structure. It's kind of house. So we have a house, like understanding simple language. So there will be a structure. Right? So when the code came and then when it is processed and then we see the so there is different structure in that. Okay, iframes are there, frames are there, outer frame, inner frame. So that is called DOM. Okay, DOM content of the page, and first that gets loaded because of the CSS file and the JS file, and then the images will be downloaded and they go and fit in all the different frames. Okay, wherever they are designed to fit into. So if you want to see the processing for any page, right, so you can use Lighthouse here. We have a Lighthouse option, and you can go here and for any page, it's a default which comes in. You see, you can click on analyze page load, You have to just click and automatically you see it will refresh that flip card. It's refreshing the flip card on left hand side, and it analyzes whole thing, right? Like what on from user perspective, like if the page is getting processed, okay, uh, on user end. So how is its behavior? Which component is taking much time, or what solution, or some recommendation also it gives, right? So for every page using this, we can do, right? So so I'm saying this because we must have an idea of this also. So suppose if it is required that if you want to check the UI side, right, the processing thing another, then you can use this lighthouse, and so it is generating a report. Which will, this lighthouse is a inbuilt plugin, especially in Google Chrome. Now it is auditing and gathering all information to complete the score. The score means like a kind of recommendation. So you see, it has when this was going on, uh, you might have observed this whole was getting loaded and processed. So you see, this is how it brings a report for every page. Like you can expand the view and you can see what what was the metrics for each page. So a detailed report to you about the client side. Okay. Especially this will give for processing stuff, which as I said, you cannot see very easily because uh, that is the thing which is going in the RAM memory. Okay, so that cannot be measured easily. So especially this kind of inbuilt tool uh, have this capability to get them done. Like, you see one recommendation like it has done. Okay, JavaScript file you can save the size. There is one CSS file like that. Okay. Some recommendation also it will give. So you can take help of this to improve the or to check the UI rendering or processing stuff. Okay. Right now, so this you can use to check that, and rest of the thing we can use the JMeter to get our work done, right? Because especially JMeter deals with load testing, sending request and receiving response from server, right? And if you want, you can download embedded resources as well in JMeter and check the response time for that also. That two feature is there in JMeter. But as I said, the first one is the more important when, like especially microservices, web APIs or web services, their rendering thing is not there. So web services is something which works between application to application. So this concept is not there. Only getting the response. Now, moving on to, ahead to the separate topic, application architecture. Okay. Application or client server architecture. It's in type design and different layers. And the different layers. So all application have some architecture using which they are designed, and they have a layers also. So what are the different layers? So three different layers in an application architecture: presentation layer, business logic layer, and DML layer. And the architectures that are there, which is one tier architecture, two tier architecture, multi tier architecture, two tier architecture, three tier architecture, and multi tier architecture. Multi tier architecture is just an extension of three tier architecture. Okay. And this each architecture is made up of the layers. Right? So we will understand. So this is one tier architecture. One tier architecture used to exist earlier, long, very, very long, like 30, 40 years back. When you have only one hardware thing and all the application stuff resides in that inside the same hard. Okay, fine. So Today example can be, suppose if you are developing something, or in engineering, if you remember, we have to prepare a small demo application, right, as a project. So that all we do a setup on our laptop, right? so so when you are using everything in one machine, right, it's one tire architecture, right? But nowadays this is not there. Then comes two-tier architecture. So in two-tier architecture, it's there, it still exists. All our mobile applications are of two-tier architecture. Okay. So two-tier architecture has two layers: client and tier and database layer. I'll be showing you also how it is different. So two layer, right? Then we have three-tier architecture. So to understand which is the main and going on nowadays, all three-tier architecture. Now, so first, let us understand in simple way. So three-tier architecture will be having three layers. First layer will be the presentation layer. Okay, presentation layer, PL layer. Now, what is the presentation layer? Presentation layer is also called a UI, user interface of the application, right? And especially this is there in web application. So any application, if you open, suppose ICSC or whatever, the content that we see, or the page, right, through which we are interacting, correct? So we are interacting with this, right? So just put a message. So this thing that you see, right, this is called front end. It's what it's called, front end. Front end means, you know the meaning of front end, which is towards the user, front facing towards the user, or it is also called a user interface, right? That is what presentation layer means. This layer is presented towards the user, correct? So uh, this stuff, um, the whole look and feel that we see, that is what presentation layer or user interface, UI layer. It's also called as presentation layer or UI layer, right? Nowadays many people are calling it as a UI layer. So same thing, user interface layer. UI UX you might have heard. And or also called as front end of the application, right? You might have also heard of this front end developers, right? UI UX developers, correct? So basically, so those people design this layer, correct? Front end developers, and the technologies that are used in designing this are, you can see this full stack. The stack is there. So front end. So HTML, which is always there. Then CSS we have JavaScript, React, Vue.js, Angular, jQuery. So this will be the technology using which that front end thing is designed. And as I said, the person who developed them, they are also called as front end developers. You might have heard of, right? Now the machine, okay, the server on which this code, or you can, yeah, all the setup or the code for this layer will be kept, that is PL layer. Okay. No, it's already clear. I'm talking about the machine, right? The server on which this whole code and whole setup for this layer will be kept are called web servers. Web servers. Okay, web service. Now next comes the next layer, which is business logic layer, BLL layer, or logic layer, or it is also called as backend, which will be why backend, because we cannot see this. Now, what is the meaning of this BLL layer, business logic layer? All the business functionality for that application, the code, the complex coding for that, right, is is there. That's why called logic layer, business logic layer. Now, one example, suppose you go to ICICI, right, or any banking, then all the thing there, right, like want to add a beneficiary, want to delete the beneficiary, some condition you want to set in your banking application, anything, right? So the whole business functionality, how the business logic for any application, there on any application we have different scenarios, different business scenarios. For that, there is functionalities there, right? Like the food, the business logic, you can say, right? Logic is correct for that. So to do that, we have to write the code, right? To apply all the logics to get all the work done. Right? That is what business logic layer, BLL layer. Uh, one example, suppose you have added beneficiary, right? And you have approved that. Now for 30 minutes, you cannot transfer the money, right? If you want to go to transfer also, it will say that you have to wait for 30 minutes minimum, right? So this kind of condition also, just one example I am saying. So like that, there are many things. So that is what whole application business thing. Because website is a static. See, if you see, this is a static thing. Okay, but when we go inside and when we do different operations, so they have to work on some logic, right? So that's the code. So that is what business logic layer, and it's also called as backend. The tools which are used to develop this layer are Python, Java, PHP, .NET, Golang, Ruby. .NET is also there. .NET is also there. And the developer who develops this layer are called backend developers. You might have heard of backend developers. Right? They are the more like, because they are, this is the hardcore of any application, right? So that, because main advanced things, advanced coding is here only. So that's what. And all this code and all this setup on it will be kept on some server, right? So that machine on which this is called app server. Okay, app server. Now comes this layer, DB layer, data manipulation layer, or data tier layer, you can say. So at the, because so simple way, data layer, database layer, because see, everything is data. Suppose your account information, your if you are using a bank from last 15 years or 10 years, like all your transaction will be saved somewhere, right? All history, you can fetch your history from 10 years back, right? Anything, any information, your photo, your everything, your emails, somewhere it has to be saved. So everything is data, right? So where that is saved, that is what DB layer, right? That is there. And uh, so the technology which are used to develop DB are MySQL, MongoDB, many are there, Oracle, SQL Server, PostGRE, these all are there. And the developer who develop this are called DB developers. But now this word has changed. You might have heard of now people coming data analyst, related keywords are there. So that is what. Now on the machine or on the server where this whole setup will be kept are called DB servers. Okay, DB servers. Now I'll show you. I'll tell you. So see, whenever a user interacts, he interacts on the web application, right? Generally, all web applications, they follow the pure three-tier architecture. So the presentation layer, or the through front end, any user will be interacting. Whenever he will be entering the website, this is the front end that will be presented and he will be entering. So let us say, suppose we open ICC and then we went to login page, right? So suppose then we entered username and password. So that request will come through this front end only, right? It will come to the BL layer. It will be processed. So what will be processing? So one example, like uh, this layer will try to fetch the existing username and password from DB, right? And it will try to match what the user has sent. If both will match, it will try to it will allow the login, and then it will fetch all the his details, right? Banking details, whatever, to from DB, and it will send that response back to the user through this presentation, right? This is how this interaction works with any website. Okay, so you can see here. Yeah. Now, different technologies stacks are there. So we got the idea till now that so these all technology stacks in IT world. You might have everyone might have heard of. So this is front end, this is back end, this is DB, and then there is DevOps, which is operations, deployment of the code and everything. So for this all is used, and this is the server infrastructure, cloud infrastructure, right? Because nowadays everyone is using cloud only. So cloud service, right? Explain that in very beginning in cloud. Somewhere this server we have to keep somewhere. So instead of people nowadays owning their own data center on server, they will rent out from these services, and then they will keep all the application on their servers. Next is this multi-tier architecture, which is actually traditional tier architecture. Now, why it's called multi? So if you see here, do you see multiple web servers are there, multiple app servers are there? Correct. Hope you see. Multiple DVs are there. So that's what actually layer is three only. Presentation layer, you can see presentation layer, logic layer, or this DML layer or persistence layer. Right? So uh, so web server. So I just said PL layer on which it is kept. Those servers are called web server. The BLL layer, the server on which these will be there is app server, and we have DB server. Now, why it's called multiple, or this is also called a distributed architecture or distributed system. Meaning of distributed is different things will be there on different machines. Like now, why that is? So see, everything in this world has a capacity. Everything in this world has a capacity, some limit, capacity limit. Anything. As a human being, you people also have, we people also have capacity, right? Someone can run 2 kilometers, someone can run 3 kilometers, someone can run 10 kilometers, someone can pick weight of 30 kg, 40 kg, like that. Everyone has some capacity. So machines have also capacity, right? So suppose you have a very good server, right, with all latest processor, RAM, hard disk, infrastructure, correct, and all the latest coding and all things kept here. But even though it will be having a serving capacity, serving means handling the users. So let us say that one server can handle 5,000 users. For an example, I'm saying 5,000 users per hour. That is maximum. Its maximum capacity. Now, assume that if 10,000 user load is coming, then what will happen? Can it handle? Can it process? It can only handle 5K. So additional 5K, what will happen to that? If only one machine is there, such machine, right? So it cannot handle, right? And that is where it will go out of capacity. Oh, that problem will come and many things will happen, right? Now, right, you got the idea. So that's why we use multiple web servers, multiple such servers combined. So suppose I want to have a 20,000 users handling capacity system. So I should have five web servers like that, right? Each one can handle 5K. Same goes for app DB, correct? So this is a small representation of the application architecture. In that, many things are also there, which we do not have to know more on that. Like load balancer is there, proxy is there, firewall is there, okay, catching mechanisms are there. So many things are there. Just one thing I'll tell you: load balancer. You will be hearing very much going forward in performance testing career. Load balancer, their main work is to balance the load. Now, what is this balancing of load, right? So, balancing of load means suppose we have five web servers. Now, who is busy? Who is handling how much? Who is free by how much? How anyone will know that, right? So that's why you see before load balancer is there. So every load first come to this load balancer, and then they decide. They check that which web server is how much busy, and depending on that. Now load means what? The request, correct? Request. So depending on which is free, the request will be routed to that, correct? To that service. And now you got the idea, right? That in very beginning, show you one architecture, one diagram.
Hi, hi, Vallabh. So we can say that this is also similar to the microservices architecture.
What is microservice architecture?
That three layers: app server, DB server, and the web server.
Hmm. Yes, fine. So, yes. So now you got the idea, right? Why there are multiple machines where are there in different racks. These machines are what? Multiple servers. Okay. But generally we do not see them because they are there somewhere in USA. Correct. We just see them through a web interface, right? Which look like this, I think. So, which look like this, right? This. The backend thing, the hardware, the building, and other thing is not in our reach. But that is the machine. Now next is thin client, thick client. So all the web applications, right? They are called thin client applications, and they follow all a proper three-layer architecture. Okay, means three-tier architecture. All three layers will be there in them. They will be multiple, but layer will be three only. Only servers can be multiple. Now in this, what will happen? Understand very minutely that presentation layer, right, is towards the user, right? User interacts towards the presentation layer. So you can say it's client facing or user facing. And we need a third party interface like browser to access or to access this application, correct? So any web application, we have to use a browser and then only we can access. But understand one thing, no component of the application is installed on the user machine. Okay, remember this. Now I'll explain also what it means. And the BL layer and the DML layer are on the backend towards the server. Correct. Now, thick client and fat client application. So all the mobile applications are called thick client or fat client application. Or desktop apps are also there. Some desktop apps. Thick client applications has only two-tier architecture. The layer one will be the combination of presentation layer and business logic layer, which is treated as layer one, and it is also called as client tier or layered client tier or client layer. And remember, that is on client side. Client means user side, and that is installed. Okay, that is installed on user machine. Here this is not installed. Here it is installed. The DML layer is centralized. Okay, centralized. Now, what is this exact difference? So let us take the example of ICIC one. So ICIC have web version. So this is web version, and we have a mobile version also. Right. So we download ICIC APK file from Android or for OS, iOS, right? iPhones, correct? So that is mobile version. Now, what is the exact difference between this is? Suppose you want to open the web version, the web application of ICC app. You have to open. You have to first get a browser, any browser, and then you enter right the URL, and then you interact through front end, that is presentation layer, then application. All thing happens in backend, but we interact through this, right, using a browser, correct? But in this, what happens? Only two layers, and this first layer is on user machine. It is installed on the user machine. Now, what is the meaning of this? And here nothing is installed, right? So what is this installation? See, the APK file that we are downloading from Google Store. So we are installing, right? We are installing on our device or authenticated device. And then first time, we have to do a setup, right? Registration and other thing. Then after that, just you put your finger or pin, and then you are inside your application and you are using it. So do you see any browser or anything there? No, right? It's complete application package is there on your device. It's just communicating for taking a data from the server, and that's why it need a internet, right? Correct. But most the all component is there in the device, right? Correct. Which is a combination of UI and other thing. But for web application, it's not like that. Right? Nothing is there on our side. We need a third-party browser, third-party software, and then we access that up. So that is the exact difference between two-tier and three-tier, thin client or thick client. Okay, all mobile applications are thick client, or they follow two-tier architecture. Like that, desktop applications are also there. Desktop applications are like they were old applications. Nowadays, desktop applications are also moving to cloud. Everyone is moving to cloud. Okay, so desktop applications were like that. They used to be on the component. Some of the application will be installed on the on machine, on the laptop, on the user laptop. Okay, whoever will be the user, or on his CPU, right? So that thing are called desktop application. It's like how mobile thing we are installing, right? So like that, those applications are also properly installed and set up on the user system. So those are two-tier architecture. You do not need a web browser to do anything in that. This is one small example of how a tier looks. Right? So you see here a proper DB, which is centralized. Switching is there. Switching concept are used to connect with each devices, right? Because they are. This is called distribution concept. Right? Many servers will be there, and they will be interconnected. So that's all. Then we have two app servers. This is just an illustration diagram. And here a web server is there, and here also web server, which is part of front end, right? And here also switch. So if you see this part here, firewall is there, here also firewall, but for this mobile people it's no firewall. I'll tell you why. So any user accessing through web. So web means the browser, correct? So he will properly open the browser and then he will enter the URL and then through presentation layer he will interact, right? So to protect the website from hacking and other thing, we have firewalls, all the things, right? So this is how things works for those guys, right? Who is accessing the website through web, correct? The request going through this and then it is coming here, processed and going back. But if there will be mobile version of that same application, so it's already secured and the components are installed on mobile, right? So there is nothing such presentation layer or concept because this is just a one layer, correct? So that those fellows directly interact with you see, this layer one, right? Because that is considered just one layer. So we will understand this more in this diagram. Here, if you see, so this is a blueprint of one application. So every application will be having a blueprint. You can ask the person on which you will be working, right? That what is the blueprint. So blueprint means all the technology used and where they are, how many they are, right? How many servers are there, where they are kept, how they are kept. That is called blueprint. Right? So this is just one example. Like so, this whole thing is there on AWS cloud, and servers are there on AWS services. Right? Two web servers are there. You can see, and the server operating system used is Windows, right? Because in server is what combination of hardware and software. So hardware is there and software we have what OS will always be there. In that application will be there, right? So Windows EC2 app servers here also two and here and it's on Linux OS, right? And then DB primary DB and then secondary DB. We have S3 thing to store the information that is a separate service by S3 bucket, and this is for catching. Redis servers are there. Catching we discussed, right? So catching how it's there on browser, same way catching concept is there on server side also. So for catching this is there. Now if you see how it works is here load balancers are there. So any user accessing this application through web, he will be properly coming through this route, right? Load will be distributed to the web servers and from there it will be coming to app servers. Data will be fetched, processed, and then it will go back like this to the back to the user who is accessing it through web application, right? The browser. But if there are the user who are accessing the same thing through mobile, so for them it becomes only one layer, right? So if you see, that's why his request is directly jumping and coming here. There is no this stuff because this stuff is already on his device, right? So that path becomes short for the mobile applications. They just do the business calculations, paste the data from DB, and show us in our app, mobile app. Database are always centralized because they are more secure because everything is data, and then so totally separate thing. And database will be common even if it's a mobile architecture or web architecture of an application because uh, let us say on web application using web application in ICSE you transfer 10,000 to someone, right? So that will be deducted from my account and it will be reflecting the database. And you can check in your mobile also, right? If you go there and open your mobile app, it will show you there as well. So this is why it's it's the same layer and it's it will be same, correct? Centralized, correct? So for every application, this is how ICIC is there. Right? So take the very simple ICIC. We have web and mobile. So whatever I do in web, that same thing will reflect in mobile also. So architecture remains same. Only the behavior of working changes. You see, behavior of working. Now, so this is one more example. So this is on Azure VM, Azure Cloud, Windows Server 2012, AngularJS and .NET is used for UI layer, business logic layer, database is SQL Server. So this is a little bit simple blueprint. Fine. So we have discussed this all till now, right? That there is a business scenario or yes, every application has business scenario, and when we do any business scenario, completing one business scenario will be called one user session, and then there will be transaction in that home page search like that. Whenever we do each transaction, you see a request, right? HTTP HTML request firing to the server. This is the server. Right? This is our server loop, the hardware part, the software part. So load goes on this, response goes back. Retrieving of embedded resources happens on front end. So this is whole thing, right? About application thing and performance, core concept. Now we will go in JMeter. So JMeter, right? So some terminologies will be used in JMeter. So remember, there is a word called threads in JMeter. So thread means virtual user. Okay, we user, a virtual user. So one thread means one virtual user. Then we have talked about requests, right? We have learned that what a request is. So requests are known as sampler or sample. And the embedded resources or non-HTML resources are called as subsamplers. We have a thread group concept also. So thread group is an element in JMeter, which will be used to hold one business scenario. Means everything start with using a thread group only, right? So inside the thread group, one business scenario will be there. It means that all the transaction or all the requests related to one business scenario will be keeping in one thread group. Right? We can have multiple thread groups depending on the requirement. Now elements. So in JMeter there are 12 major elements or 12 major components. So I have highlighted them in bold. Test plan, non-test element, thread groups, sampler, logic controller, config element, timer, assertion, listener, preprocessors, post-processor, and test fragment. Okay, so that's JMeter open. So you see, first time whenever you will be opening JMeter, test plan will be there, right? So test plan is everything. It's the main element. Or you can say it holds everything. Now, when you right click on test plan, right click, you will observe add, and then you'll observe this stuff, thread and thread group. Just now I talked about thread and thread group, right? Thread group. Then we have config element, listener, timer, preprocessor, post-processor, assertion, test fragment, and non-test element. Right? So I'll just give a brief, small introduction about each element. So test plan. Test plan is the main element, right? It's like the root. It holds everything. Everything starts with test plan. Now, when you right click on test plan, if you right click add and you see non-test element, you see non-test element and it has 3-4 sub elements. Every element has sub element. You see sub elements, right? These are called sub elements. Right? So every element has sub elements. Okay. So non-test element and These are non-test element. And this one, HTTP test script recorder. Do you see this? This is one of the very important non-test element we will be using, and I'll be telling you also why we'll be using that. So we have non-test element, right? And this is a very important element of non-test element, the recorder, HTTP test system. So non-test element are used for recording, and it is only present at test plan level. Means when you right click on test plan, you can see this non-test element. Then we have threads and thread group. So they act as a scenario, and they will be continuing all transaction and requests related to a scenario. So if you right click here, you see a thread and thread group. So many thread groups are there, but default one is this one, the second one that is. So everything starts by adding a thread group. So when you click on that, thread group will be added. Now inside this thread group, we will be keeping all the things, all the transaction, all the requests, right? So for one business scenario. So if you have multiple business scenario, we will be having multiple thread groups, correct? So that also will observe. Do not miss. Fine. Now we have sampler and logic controller. Sampler and logic controller I'll show you later. Then we have config element. So config element, if you read the definition, they are configuration element and used for applying available setting in the test plan. So if you right click anywhere, if you right click here and go to add, you see config element, and these are the config. So this is the config element. Or if you right click on thread group also, if you go to add and you see config element is there, right? Config. So config element are some configuration element used to apply different setting depending on requirement. Right? Then we have timer. Okay, timers are used to apply a think time or wait time and pacing in JMeter. So what is that? We will observe later on. But for now, understand that time related activity. So any time related activity for that timer is used. Okay. Wait. How many people are? 10 people. Am I not audible clearly to you guys?
You're audible.
Okay.
Audible.
Yeah. So if you right click anywhere, like test plan and add, you see timer, and there are so many timer here. Or if you right click on thread group, you see timer, and we have timer, right? Same. So timer, correct. Then we have assertions. So assertions are used for verification and validation of response data as well as business functionality. It means that suppose you are sending a request and a response comes. Now you have to verify the response, correct? That whether it is correct or not, like how much time it has taken. So for that validation or verification, we have assertions, right? Or we can verify business functionality or also using assertions. So I'll be teaching. So we have assertions. So if you right click anywhere, you will see add assertions here, and these are the assertions. Then here also, if you right click, you see assertion, and these are the assertions. Then we have listeners. Listeners, simple way if you understand, listener listen the result and display them to us. So they listen the result from JMeter or whatever the test we run from that, and they display it to us. So that's why it's called listener, right? So they listen the result and different test statics or metrics and display those results to us, right? So if you right click anywhere, you see listeners will be there, right? Listeners. Or here if you right click, we have here listeners. Same means it's same. Anywhere you right click, will get them. Now we have preprocessors. So preprocessors are executed before the request, and hence they are used to do some action before the request. Means suppose a request is fired, and before the request, if you want to do something, we can use preprocessor. But there are very few preprocessor which we can use. Other are waste. They are not that much useful. So if you right click anywhere, you'll see preprocessors. They are less in numbers. Preprocessors. Then we have post processor. Post processor are executed after the request. Means if you want to do something after the request, when the request got fired, and after that you want to get some work done or do something, we use post processors, right? So again, if you right click anywhere, you'll see post processors. This one or here also post processor. And then we have last one, test fragment. Test fragment is an individual element. It has nothing, no such important use. So if you right click anywhere, you'll see test fragment. Here it's a single element. Okay. Or here also test fragment. Okay. So how much I have shown you? I have shown you till now 10. Okay. So if you count it, test plan is 1, and right click on test plan, we have thread 2, config element 3, listener 4, timer 5, preprocessor 6, post processor 7, SSN 8, test fragment 9, and non-test element 10. 10 elements. Okay. Major elements. Each element has sub element. So we are not going into sub element 4 now. We are talking on major. Now I have written here 12. So where are the other two? Right. So other two are sampler and logic controllers. So sampler, they are request and they are presented only at thread group level. Okay. They act as a request. I'll show you. And there are logic controllers. So total 17 logic controllers are there by default, and one plugin is there. So total 18 logic controllers are there. So they control the execution flow of the transaction inside a thread group or inside a scenario. Right? And they are also present only at thread group level. Now, what is the meaning of this level of thread group? I'll also explain that. So for now, first right click here, thread group, and go to add, and you see sampler, and these are the samplers. And below that you see logic controller, and these are the logic controllers. Okay, 18. So where you find that, you will be finding them when you will be right clicking on thread group, and you see these two, sampler and logic. That's why I have written that they are only found at thread group level. Means all other element, like let us say if you click on test plan, you'll get all other element, right? Especially config, listener, timer, preprocessor, post processor, assertion, test fragment, all are here. If you click on thread group also, you see this will be there, pre, post, assertion, timer, test fragment, config, they are there, right? But these two elements, the sampler and the logic controller, only when you right click at thread group, you see them. Do you see them, right? Both. But if you right click on test plan, you are not going to see that, right? So that is called label. Which element is presented, which element. At test plan label, when you add, you see non-test element will be there. But this non-test element will not be there when you right click on thread group. Okay. And same way, yeah. So that's why. That is the label. Okay. So this you will find only when you right click on thread group. This you will find only when you right click on test. All other, apart from that, all other elements like this, and this. Anywhere you right click, you will get them. Okay. You will see them. It will be available. So why so? No need to worry about that. Okay. Why that is there? Why that is there? No need to worry. So that's what I have highlighted here. Each element and their sub element which will be covering. Correct. Just for reference purpose, you can see here 3 non-test element, 7 thread group, 18 logic controllers, 10 samplers, 11 config element, 4 5 assertions are there, 6 timers are there, 4 preprocessors, 7 post processors, listeners are there. Okay. So if you just count them, they will be more than 100 or 90, 70, 80 plus they are there. 70 plus elements. So now we'll start using JMeter. So we will start with the test plan. Initial some element, we will have an introduction. So we'll add a thread group, recording controller, recorder, and then and then we will start the recording. We'll talk about recording in JMeter and port and proxy server. Now, what is this recording? First, understand that. And for this recording, this element is used. Right click here and you see this recorder. This is recorder. Now, what is this, right? So, if I go to the PTLC, let's say here. So, as I said, our main work starts from phase 3, test scripting. Right? So, in test scripting, it is also divided into 2-3 parts, right? So, first part is identification and documentation of the business scenario, right? Or now you got right what is business scenario and the transaction involved in that, right? So, identifying them and documenting them means writing them to some file in some documents. Right? Then we have a script recording. So once that is finalized, so first thing start is the thing starts with recording the doing the script recording, which is basically recording or capturing the request and response for each transaction of a particular business scenario. And suppose you have identified multiple business scenario to work on, right? So we will be starting with initially with one business scenario. Now in that business scenario, there can be multiple transactions, right? So the work start by recording or capturing the request and response of each transaction in that particular business scenario of the application on which you will be working. Correct? So capturing or recording. And once that is done, then we do enhancement and other things. So that is another phase. Now you understood recording, right? So recording is means like the example, like this example which I have shown in very beginning. Like suppose I was doing one transaction. Suppose we did home page launch. So this request fired. Then we clicked on one refrigerator or something, if you remember. So that was another transaction, and this request was fired, right? Then we have chosen Godrej refrigerator. That was second another transaction, and then this request was fired. Then we clicked on buy now, and then these two requests were fired, right? Another transaction. So you see what is happening. The request is firing, right? So we have to capture this request or record this request. Why to record? Because we need this request. Suppose you are going to do a product booking on Amazon. So this is how you will be doing, right? Or anything, any scenario when we perform. Basically, what is it? It's a request, right? In the user interface of the website, we do so many things here. But at the end of the day, what is that? At the end of the day, it's click only, and click is going to do what? It's going to send a request on. This is what the truth. This is what the truth, the real thing. Correct. So so suppose you are doing a product booking, like on Flipkart. I have shown you, right? Some 8-9 steps are there if you want to do a product booking. So at the end of the day, for every transaction, what is happening? Those many requests is getting fired, and this request is what we need. Correct. Because we have to fire this request. We have to make these things implemented in tool, any performance testing tool, let us say. So we'll be using JMeter to do that, so that JMeter can fire these requests, right? Because real user is also firing. So now let us say we are going to do performance testing for 1000 user, 2000 user, 5000 user, 10,000 user. Now we cannot bring real users, right? Even if you bring real user, what real user are doing? They are just firing this request. So now instead of real user firing that, we will make the tool in such way that they will be firing this request. So for one user, if you do they will be firing. If you run for 2 users, so 2 user will be firing this. If you run for 100 users, so 100 user will be firing. Tool will generate the virtual users, and all those 100 user will be firing this. And in this way, we will be having 100 user load, right? Or 1000 user load on the server, or 2000 user load. So everything starts with request, correct? And that is what we have to capture. So that is why that is what we will be learning about the capturing basic thing. First, we'll be talking about something on capturing. Okay. So we will be using 4 initial elements, and then we'll be talking about how this capturing works. Correct. We have to set up port and proxy. That is called recording. Right? Recording of the request and response. So there will be 2 sessions on discussing this stuff. Right. So like that, we will proceed ahead. So that is for today. So thank you for attending.